Now let's study about similarity. Two figures are called similar if they have same shape, not necessarily the same size. Which of the elements would determine the shape of a triangle? The angles determine the shape of a triangle. Yes, the statement that two triangles have same shape simply means that there is correspondence between the angles that have same measure. Photograph of an object and its enlarged copy, mini model of a building and the original building, etc. have the same shape but they differ in size. Now let's do an activity. Cut out a triangular figure. Hold it between a point of source of light and a wall. Observe the shadow cast by the figure on the wall. The shadow will have the same shape but is larger in size. The shadow A1B1C1 is similar to the original triangular cutout ABC. Tests of similarity of triangles. Observe the pairs of triangles given below. State the test and correspondence of similarity. Number 1. In triangle ABC and triangle QRP, angle B is congruent to angle R. Angle C is congruent to angle P. Therefore, triangle ABC is similar to triangle QRP by AA test of similarity. Therefore, ABC corresponds to QRP. Number 2. In triangle MNA and triangle SKL, side MN upon side SK is equal to 5.6 upon 2.8 is equal to 2. Side NA upon side LK is equal to 2.6 upon 1.3 is equal to 2. Angle N is congruent to angle K. Therefore, triangle MNA is similar to triangle SKL by SAS test of similarity. Therefore, MNA corresponds to SKL. Number 3. In triangle DEF and triangle PQR, side DE upon side PQ is equal to 2 upon 4 is equal to 1 upon 2. Side EF upon side QR is equal to 4 upon 8 is equal to 1 upon 2. Side DF upon side PR is equal to 3 upon 6 is equal to 1 upon 2. Therefore, triangle DEF is similar to triangle PQR by SSS test of similarity. Therefore, DEF corresponds to PQR. Properties of similar triangles. Number 1. Reflexivity. When two triangles are similar to itself, then it is called reflexivity. Example, triangle ABC is similar to triangle ABC. Number 2. Symmetry. If triangle ABC is similar to triangle DEF, then triangle DEF is also similar to triangle ABC. Number 3. Transitivity. If triangle ABC is similar to triangle DEF and triangle DEF is similar to PQR, then triangle PQR is similar to triangle ABC. Let's look at an example. In the given figure, QR upon QS is equal to QT upon PR and angle PQR is congruent to angle PRQ. Show that triangle PQS is similar to triangle TQR. Solution. It is given that angle PQR is congruent to angle PRQ. Therefore, PR is congruent to PQ as they are the sides opposite to congruent angles. Let us mark this as statement 1. Now, it is given that QR upon QS is equal to QT upon PR. Therefore, by substituting PQ for PR from statement 1, we get QR upon QS is equal to QT upon PQ. Therefore, by dividend, QR minus QS upon QS is equal to QT minus PQ upon PQ. Therefore, SR upon QS is equal to PT upon PQ. Therefore, by converse of basic proportionality theorem, we get PS parallel to TR. Considering PS parallel to TR and transversal QR, we have angle PSQ is a congruent angle TRQ as they are corresponding angles. Let us mark this as statement 2. Now, in triangle PQS and triangle TQR, angle PQS is congruent to angle TQR as they have a common angle Q, and from statement 2 we get angle PSQ is congruent to angle TRQ. Therefore, triangle PQS is similar to triangle TQR by AA test of similarity. Now let us solve few examples. Example 1. From the information given in the figure, state whether triangle RES and triangle PEA are similar. If so, state the test and the correspondence. Solution. Let us find the ratio of the larger sides of both the triangles. RE upon EA is equal to 15 upon 12 is equal to 5 upon 4. Let us mark this as statement 1. Let us now consider the ratio of the smaller sides. SE upon PE is equal to 10 upon 8 is equal to 5 upon 4. Let us mark this statement as 2. Therefore, from statement 1 and 2, we get RE upon EA is equal to SE upon PE. Now, triangles RES is congruent to triangle AEP as they are vertically opposite angles. Therefore, in correspondence, RES corresponds to AEP. Thus, triangle RES is similar to triangle AEP by SAS test of similarity. Example 2. In the given figure, altitudes AD and CE intersect each other at the point P. Show that number 1. Triangle AEP is similar to triangle CDP. Number 2. Triangle AEP is similar to triangle ADB. Solution. Number 1. In triangle AEP and triangle CDP, angle AEP is congruent to angle CDP as each of them are 90 degrees. Angle APE is congruent to angle CPD as they are vertically opposite angles. Thus, triangle AEP is similar to triangle CDP by AA test of similarity. Number 2. In triangle AEP and triangle ADB, angle AEP is congruent to angle ADB as each of them is 90 degrees. Angle PAE is congruent to angle DAB as they have a common angle. Thus, triangle AEP is similar to triangle ADB by AA test of similarity. Example 3. In the given figure, if triangle AMN is similar to triangle ACM, show that triangle AMN is similar to triangle ABC. Solution. It is given that triangle ABN is congruent to triangle ACM. Therefore, by corresponding sides of corresponding triangles, segment AB is congruent to segment AC and segment AN is congruent to segment AM. Therefore, AB upon AM is equal to AC upon AN as they are the ratio of congruent sides. Therefore, by invertendo, AM upon AB is equal to AN upon AC. Let us mark this statement as 1. Now, in triangle AMN and triangle ABC, from statement 1, we get AM upon AB is equal to AN upon AC and angle MAN is congruent to angle BAC as they have a common angle A. Thus, triangle AMN is similar to triangle ABC by SAS test of similarity. Now let's start with exercise 1.3. Question 1. Triangle ABC is right angled at B. D is any point on AB. DE is perpendicular to AC. If AD is equal to 6 centimeters, AB is equal to 12 centimeters, AC is equal to 18 centimeters, find AE. Solution. In triangle AED and triangle ABC, angle A is a common angle. Angle AED is equal to angle ABC as both are 90 degrees. Therefore, by AA test of similarity, triangle AED is similar to triangle ABC. Now, AE upon AB is equal to AD upon AC as they are congruent sides of similar triangles. By substituting the values, we get AE upon 12 is equal to 6 upon 18. Therefore, AE is equal to 6 into 12 upon 18 is equal to 4. Thus, AE is equal to 4 centimeters. Question 2. In the given figure, E is a point on side CB produced of an isosceles triangle ABC with AB is equal to AC. If AD is perpendicular to BC and EF perpendicular to AC, prove that triangle ABD is similar to triangle ECF. Solution. In triangle ABD and triangle ECF, angle EFC is equal to angle ADB as each of them are 90 degrees. It is given that AB is equal to AC. Therefore, angle ABC is equal to angle ECF as opposite angles of equal sides are equal. Therefore, triangle ABD is similar to triangle ECF by AA test of similarity. Question 3. D is a point on side BC of triangle ABC such that angle ADC is equal to angle BAC. Show that AC square is equal to BC into DC. It is given that angle ADC is equal to angle BAC. We have to prove that AC square is equal to BC into DC. Solution. It is given that angle ADC is equal to angle BAC. Angle C is the common angle. By AA test of similarity, triangle ADC is similar to triangle BAC. Therefore, DC upon AC is equal to AC upon BC as they are congruent sides of similar triangles. Therefore, AC square is equal to BC into DC. Question 4. A vertical pole of length 6 meter casts a shadow of 4 meter long on the ground. At the same time, a tower casts a shadow 28 meters long. Find the height of the tower. Solution. It is given that DC is equal to 6 meters, ED is equal to 4 meters and BE is equal to 28 meters. Tower and pole stand vertical on the ground, so they are perpendicular to the ground. Therefore, angle D is equal to angle B is equal to 90 degrees. In triangle ABE and triangle CDE, angle E is a common angle. Angle D is equal to angle B as both are 90 degrees. Therefore, triangle ABE and triangle CDE are similar by AA test of similarity. Therefore, AB upon CD is equal to BE upon DE as they are congruent sides of similar triangles. Now, by substituting the given values, we get AB upon 6 is equal to 28 upon 4. AB is equal to 28 into 6 upon 4 is equal to 42. Thus, the height of the tower is 42 meters.